Yeah, I think, yeah, recording is on. Okay, so moving from group 1 till group 7, the size is decreasing. Okay, the atomic size is decreasing. So, across the period, we know that nuclear charge increases, atomic radius decreases. So, the fluorine atom, greater attraction between nucleus and the bonding electrons. So, electronegativity increases. So fluorine, the nucleus will be much closer to the incoming electron, or we can say even the electrons within the atom. Okay, they will be much closer to the atom. So the electronegativity will be greater. Clear? So the most electronegative atom is fluorine in your whole periodic table. That is the most electronegative atom. Okay. So these were our variations. Then moving on to the next thing, that is, okay, these are all the variations, that general trends that we had to study. Now we will move on to some reactions that are included in periodicity. Okay. So first is the in because we will be studying the chemical properties, that is, I would write a heading of chemical reactions in periodicity. Okay, so the first reaction that we have to study is reaction with oxygen gas. O2. Okay, so we'll be moving, okay, across the period 3. So the first element that we have is sodium. Sodium, how it will react with oxygen? Sodium will be, if we look closely, it has orange yellow flame, okay, and it forms white sodium oxide. Sodium burns with, you should remember the flame colors as well, orange yellow flame, and forms white, okay, white color sodium oxide. The equation will be Na solid plus O2 gas, Na2O, that is a solid, white solid. Okay, clear? Okay, you can write bright yellow as well. Okay, because we have different type of namings, but you can write bright yellow as well. Okay, I'll just balance it. Okay, now the balancing is done. Then we have after sodium we have magnesium. Okay, magnesium burns with, I would say, white flame. Okay, and that is a very brilliant white with super white, or you can say brilliant white flame to form again white magnesium oxide. Equation is quite simple. You have magnesium solid, then oxygen gas, then you have MgO. We can balance it like this. Okay, now for aluminium. So if we take an solid aluminium, okay, solid aluminium will not react with the oxygen because it has a coating of oxide layer. Okay, oxide, it is a coating of oxide layer on the outer surface. So oxygen, obviously will not react with oxygen. So to react aluminium, we first have to convert it into a powdery form. Then aluminium will be able to get reacted. Okay, so you have to remember this thing. Aluminium has an oxide layer which prevents it from reacting with O2. So powder aluminium is used, and it again gives white flames. Okay, not that much white, but it is a white flame. It burns with white flame to form aluminium oxide. So we can place it 2 here, then it is 3, and this will be 4. Okay, clear. Then we have silicon. Silicon burns slowly at red heat. Okay, Silicon burns slowly at red heat to form silicon. We also get silicon dioxide, you can say, or silicon 4 oxide. Okay, why do we call it silicon 4 oxide? Because one silicon is bonded to actually 4. Okay, and this is bonded to another silicon. This is, the giant structure of silicon dioxide. I think you have studied it. So the equation is quite straightforward. Red heat means it does not produce flames. Okay, because we already know that it has a very high melting point. We studied that in our melting boiling point trend. So it does not react vigorously or instantly. Then we have phosphorus. Phosphorus burns with a white flame. Okay, and it formed two oxides. To form covalent oxides, not oxide, not only one, because phosphorus has more than one oxidation state, so it can form other oxides as well. So these are, phosphorus 3 oxide and phosphorus 5 oxide. The equations will be P4. Okay, phosphorus remain as P4. O2 to form P4O6. Now you have to balance it. You can just place a 3 here. Okay, this will be formed if oxygen is in limited. Okay, if oxygen limited, then this will be formed. Phosphorus 3 oxide. But if we have oxygen in excess, then P4 solid. Now we have 5O2. P4O10. The oxygens have increased in numbers. Okay, this is just the difference between them. So why we are calling it phosphorus 3 oxide? Because in this phosphorus is of +3 charge and in this it is of +5 charge. The oxidation states are two different. Okay. Mm, of oxidation states, yeah, it is very important. You should know each and every equation. Okay. No, phosphorus trioxide you cannot call it. Phosphorus, this 3 means, this 3 denotes the current oxidation state of the phosphorus element. Okay, like you have copper. I write it like copper 1 oxide, and you have copper 2 oxide. So these, so I cannot call it like copper dioxide. That is something else. Okay. So for di-tri, we refer to the suffix, okay, to the second element, to the oxide. And these numbers, we are referring to this first element, the oxidation of this first element. Clear? Then we have sulfur. Now we are in group 6. Sulfur burns with a blue flame to form sulfur dioxide gas. Burns in oxygen with a blue flame. Also, you have to remember the flame colors to form SO2 gas. Equation S solid plus O2 SO2 gas. Now, under suitable conditions, this sulfur dioxide can further be converted into sulfur trioxide. Okay, so we can convert this into using the contact process. We can further convert it into sulfur trioxide. SO2 gaseous plus O2. Now this is a reversible reaction, not a straight reaction. This is formed. Okay, in this you also should remember both equations. Then coming on to the 7th, that is chlorine. Chlorine basically forms several oxides, because now chlorine also have many oxidation states. Several oxides like Cl2O, okay, and Cl2O7. But the reason, one thing is that it will not react readily with oxygen. Okay, it takes time. It will not react directly with oxygen. And argon, for okay, there's no need to remember the equation. Okay, but if you do need to remember, you can just write a basic equation like Cl2O, then you just have to balance the equation. Clear? Then we have argon. Argon does not form any oxides. So we can see, finally we can see that the reactivity, okay, is decreasing across the period. Across period 3, reactivity towards oxygen decreases, and one of the reason is because the we call it reducing power. Reducing power means tendency, that the element needs to be oxidized, that is being decreased, because oxygen does what? It oxidizes the other element. Okay, so that tendency, that ability is decreasing across the period, so the other element will not be oxidized easily. Okay, clear. Now moving on to our next series of reactions that are with chlorine gas. Cl2. Okay, so again we'll start with sodium. Okay, then we'll see the reaction with water, but that will only be of two, that is sodium magnesium. So the reactions with chlorine, sodium will be same. Okay, it will orange yellow, or you can say the bright yellow flame, just the equation will be a little bit changed. We'll just add the chlorine, okay, instead of oxygen. Sodium burns with orange yellow flame and forms again white sodium chloride. This will be Cl2, this will also be changed, because sodium compounds, solid compounds, are mostly what? White, or dull in color, not colorfuls. So this will be Cl2, this will be NaCl, and now you can just balance it like this. Okay, for the magnesium will also be same. magnesium chloride. This will be Mg and Cl2, then it forms MgCl2. Okay, now for the aluminium we have two scenarios. Aluminium forms aluminium chloride, okay, ionic aluminium chloride, at low temperature and at high temperature. So there are two scenarios. At low temperature it will be forming another aluminium chloride, and at high temperature another. So at high temperature we have aluminium, simple aluminium chloride, okay, that will be formed like this: aluminium solid Cl2 forms AlCl3. Okay, this will be the basic equation, and you can just balance it. Now, but at the low temperature, low temperature means that 180 degrees is a low temperature in that scenario. Okay, aluminium forms a dimer. Okay, do you know what is a dimer? So aluminium, yeah, two molecules combine with the help of coordinate bonding. So now it will be Al2Cl6. So these are two scenarios, at low temperature and at high temperature. Clear? So at high temperature this dimer breaks down into small simple molecules that are AlCl3. Silicon, silicon is again same, okay, and just few more things to add in it. Silicon burns slowly at red heat to form SiO2. So we'll change it to silicon 4 chloride, or now you can say tetra chloride, okay, because one Si will be having 4Cl, and like this the chain goes on. And this color, it will be a colorless liquid, okay, silicon 4 chloride will be a colorless liquid which vaporizes. Basically it will be a volatile colorless liquid. So we'll just write the equation. Si plus Cl2 results is SiCl4, that is a liquid. Okay, then we have phosphorus. Phosphorus again forms a two chlorides, forms mixture of two chlorides. So it will be again a phosphorus 3 chloride and phosphorus 5 chloride. PCl3 and PCl5. Again excess oxygen, PCl5 will be the major product. Sorry, excess chlorine. Chlorine limited and chlorine excess. P4Cl2 PCl3 P4Cl2 PCl5. So this is a solid gas, this is a liquid. Okay, and solid gas, this will again be a solid, not liquid. Okay, so these equations are very important. Okay, they does come a lot in this question, okay, related to this chapter. So PCl5, oh sorry, PCl3, I would say, is a fuming liquid, or you can say volatile liquid, while PCl5 is off-white solid. Then we have sulfur. Yeah, PCl5 is volatile liquid. Okay, let me confirm it. PCl5 is a solid, but it sublimes, which means it can directly convert into, you know, gaseous form. But at room temperature, it is something like this. It is a off-white, you can say, crystalline solid. Okay, you can search it yourself on the internet as well. Yeah, so now just confirm it with your teacher as well. Okay. So sulfur burns in chlorine gas to form disulfur dichloride. That is a orange, evil, very bad smelling liquid, or we can say evil smelling liquid. Solid sulfur Cl2, disulfur means S2, and dichloride means Cl2. That is a liquid. Okay, then moving on to chlorine. So